Hello and welcome to this video about the basics of exponents part 2. The learning target of this lesson is learning how to apply the power rule and understand negative exponents. So part 1 recap, let's start there. First was the core idea. And the core idea is that exponents are repeated multiplication. So exponents are repeated multiplication. So we just have to keep that in our back pocket and be mindful of that. The second thing is that we can expand exponents to create or derive the product rules, or the product and quotient rules. And those rules are the following. So if we have a base, a to the m, and then we're timesing it by something else, a to the n, where m and n could be the same number but are probably different numbers, you just add the exponents together. And we saw that in part 1 by expanding it out. Likewise, if we are dividing two things with the same base but different exponents, you simply subtract the exponents. So that's what we learned in part 1. Part 2, we're going to start talking about a new rule, which is the power rule. And so, again, let's be a little more abstract and theoretical and use a variable. That's if we take a base with an exponent and we raise it to another exponent. The rule is that you can multiply these together. And so let's now try it with some numbers. Let's say we add 2 to the third times, or raised to the second power. Well, remember how the core idea is that exponents are repeated multiplication. Let's focus on this squared. What this means is that we have 2 to the third written 2 times. And then we can continue to further expand 2 to the third as 2 times 2 times 2 times 2 times 2 times 2. And then we count. How many 2's do we have? 1, 2, 3, 4, 5, 6. 2 to the 6th. Well, we could avoid all this work if we simply multiply these together. 2 to the 3 times 2, which is 2 to the 6th. And so that's the power rule. So what I want to do is just walk through a few more examples with you so that way you can see how it works. So now let's say we had 5 to the 4th squared. So that's going to be 5 to the 4 times 2, which is equal to, oops, sorry, not 8, 5 to the 8. We box that and walk away. Likewise, let's, if we had something like 3 to the 5th, all that raised to the 4th power, that is 3 to the 5 times 4, which is 3, oops, to the 20th. And so that's the power rule. Now, where it can get a little more complicated is if we start to combine some of these rules. So let's say we had 2 to the 4th times 2 squared all over 2 to the 3rd. Actually, you know what? Let's not do 2 to the 3rd. Let's just leave it at this. And then we raise this to the 3rd power. So here, got a couple of options. We could either distribute this in or do order of operations and address what's going on with the parentheses. So that's what I'm going to do. I'm going to use order of operations. 2 to the 4th plus 2, because that's the rule I use. And then that gives me 2 to the 6th, all that raised to the 3rd, which would equal 2 to the 18th. Likewise, we could do this with a fraction. So we could have 2 to the, let's say, 8th over 2 to the 5th, and then we square the whole thing. So we'll apply the quotient rule here. That's 2 to the 8 minus 5, and then that's all going to be squared later. So that's 2 to the 3rd and we're squaring that to get 2 to the 6th. So the quotient, or sorry, the power rule could also be used in conjunction with either the quotient rule, the product rule, or even both. But now I want to talk about negative exponents. And so I'm going to start by stating the rule again. A to the negative n is equal to 1 over a to the n. Now you might be thinking to yourself, okay, what does that mean? How do I use that? Well, let me show you. Let's say we had 2 to the negative 3. That becomes 1 over 2 to the third power. Now you might be wondering, why does this work? So let's try to think about it using some of our rules. Let's say we had something like, I don't know, 2 squared over 2 to the 5th. Well, if we were to expand that out, we would have 2 times 2 over 2 times 2 times 2 times 2 times 2. Right? 2 2's in the top, 5 in the bottom. Well, we start canceling some of them out, we're left with 1 over 2 cubed. But if we simply applied the quotient rule at the very beginning, we could have gone 2 squared minus 2 to the, or 2 to the 2 minus 5, and that would get us 2 to the negative third. And again, like how do you repeat multiplication if there's a negative exponent? That kind of breaks our system, breaks our rules. But when we think about it, in its expanded form like this, it makes more sense. There's got to be more 2's down here. And so anytime you have a negative exponent, it becomes positive by moving it down to the denominator. So just to show you some more examples, let's say we had 4 to the negative 5. That's going to become 1 over 4 to the 5th. If you have 9 to the negative 2, that becomes 1 over 9 squared. And so negative exponents, while they look tricky, just follow one simple rule, which is you have to move them down to the denominator. Now I'd like to talk about one loose end that I forgot to mention earlier in parts 1 and earlier in this video. And that's another rule of exponents. Anytime you have a base raised to the power, and the exponent is 0, it's just going to equal 1. So regardless of what the number is, 10 to the 0, 1. 9 to the 0, 1. And that's simply because, again, can you think about if we had something like, let's say 10 squared over 10 squared, and you expand it out, 10 times 10 over 10 times 10, the 10's cancel each other out, leaving you with just 1. And if we use these rules of exponents, 10 to the 2 minus 2, you're going to get 10 to the 0, and it has this, like these are all the same thing. These are all equivalent expressions, and so anything to the 0th power is just 1. And while we're stating it, we might as well just state more things that are obvious. Anything to the first power is going to be itself. So 8 to the first power is 8. 63 to the first power is 63. So just to kind of wrap everything up, we now have the basics of exponents under our belt, hopefully, or at least have been exposed to them. A couple of things we just need to keep in mind. Again, the core idea, repeated multiplication. So all these rules, all these ideas are based on the idea that, this is repeated multiplication. Then we have to have the rules in our back pocket. So we have the product rule. A to the m times a to the n is equal to a to the m plus n, where we add the exponents. If we are dividing bases with exponents, we are allowed to subtract the exponents, minus n. There we go. And then we talked about the power rule, which is if you take a base and an exponent and you raise it to an exponent, you multiply the exponents together. We talked about what to do with negative exponents. And so if you have a negative exponent, you move it down to the denominator like that. And finally, we have some of the basics, which is anything to the 0th power is 1, and anything to the first power is itself. And so the problems you're going to see with exponents are all based off of some sort of combination or variation of these rules right here. So good luck with your practice and homework, and let me know if you have any questions.